Good morning. We're going to take a look at this problem. Third time's a charm for me. I just did this whole video and the sound didn't work. Hopefully the sound is working now. All right, so graphing inequalities, a little extra practice here. The big difference between graphing an inequality and graphing an equality, you didn't hear that, is that graphing an inequality, we have to deal with the open versus closed lines. So let's talk about that really quick. A closed line means that the two sides could also be equal. So we're going to be using these two signs. And a closed line is just like the graphs you're used to. It's going to be a solid line. And a closed line means that that boundary line that we draw is going to be included in the solution set, so that everything along that line will create a true statement if I were to plug those points into the inequality. As opposed to a closed line, we'll have open lines. And an open line means that the boundary line does not get included in the solution set. It's going to be a dashed line. So let's take a look at our first problem. Now I'm going to so the first thing I'm going to do is I'm going to assume each one of these is an equality so that I can determine my boundary line. So being careful not to pull my microphone out of the cord and not realizing it, I'm going to assume that this is actually y equals -1. For this one, I'm going to assume that x is equal to 3. For this one, I'm going to assume that y is equal to 1/2 x plus 2. Now, obviously, this is not what is given to us, but when it comes time, I'll deal with these later. When it comes time to find the boundary line, it is most productive to just assume the equals and then deal with the inequality afterwards. So here we go. So the first thing that I notice here is y is equal to -1. Well, where is y equal to -1? Well, we have a y-intercept of 0, 1 right here. And what is my slope? Well, I could also say that y is equal to -1 plus 0x, and 0 times x, you're right, would be 0. So I'm not changing the expression at all, which means that there is no change in this slope. I'll create a horizontal line where y is equal to -1. So I can just go ahead and draw my horizontal line here. So since we have a greater than or equal to sign, that means we're going to have a closed line, so I don't need to turn into a dashed at all. That's good. So now we need to figure out which side we're going to have to shade to. So I'm going to pick the point 0, 0. Why am I picking 0, 0? Picking 0, 0 because 0 is the easiest number to add, subtract, divide, and multiply. So let's plug in 0 for our variables. When I do that, I get 0 is greater than or equal to -1. Now that is a true statement. No, but it's not. It is a false statement because 0 is not bigger than -1. So since this is a false statement, I know that 0, 0 is not going to be in the solution set. Therefore, when I shade, I need to shade the region that 0, 0 is not in, which would be above the line. So there we go. My next question, we don't have y at all, just like we didn't have x over here. Now, with y is equal to -1, I got a horizontal line. When I have x equals something, what kind of line do you think we'll get? I think you're probably right, but let's just double check. So we know x is equal to 3. So Here's where x is equal to 3, right here on the line. So that is 3 comma 0. Well, where else is x equal to 3? Well, x is 3 here, and here, and here. And, oh my goodness, I'm making a vertical line. Excellent. I can't help but notice that this is not a function. It would royally fail the vertical line test, whereas this one here is a function because it does pass the vertical line test. And so let's look at the inequality. And the inequality says that x could, in theory, equal 3, which means that we don't need to turn this into a dashed line. We still have a closed line. So this line is included in the solution set. So now we need to determine which side of the line needs to be shaded, because the shaded region shows where we would have a true statement. So let's plug in 0. So we get 0 is less than or equal to 3. That is a true statement, isn't it? 0 is less than 3, which means 0 comma 0 is inside the shaded area. So I'm going to shade everything to the left of the line, because when I plugged in a point on the left of the line, I got a true statement. Oh, I should have done my little Zamboni thing. Okay, there we go. For our next expression, we have a more traditional looking equation where we have a y-intercept of 2. So I'll put in 2. And we're just trying to find the boundary line right now. We're not going to worry about this symbol quite yet, the inequality symbol. And so we have a slope of 1 over 2. So that is 1 up over 2. 1 up over 2. 1 up over 2. And I can go backwards too. 1 down to the left 2. And here we go. Now, unlike the first two, this problem cannot be, the two sides cannot be equal, which means we have an open line. Therefore, we need to take our eraser and create a dashed line. There we go. And finally, we need to know which side of the line contains our solution set. So I plug in 0 comma 0, and I get 0 is greater than, well, 1/2 times 0 is 0. So we get 2. Is 0 greater than 2? No. No, it isn't. So 0 comma 0 is not in the solution set, which means it is not in the shaded area or shaded region. So I'll go ahead and shade away because I ended up with a false statement. All right. Let's try the next one. Now we have a y-intercept of 0. So that means for my last step, I'm not going to be able to pick 0 comma 0 because it'll be on the line. All right, so then we go up 2 over 3, up 2 over 3. Let's go backwards, down 2 over 3, down 2 over 1, 2, 3. That's not right. There we go. You never saw that point. And now we can connect the dots. And again, y cannot equal 2/3 x. So therefore, this boundary line is not part of the solution set. So I need to turn it into an open line. There we go. And now let's pick a point that is not on that boundary line. I like this point right here. 1s and 0s are pretty easy to deal with. Keeping with our color scheme here. Oh, jeez. All right, I was all excited to get a smartwatch where I could see my text, but now that I'm getting like 50 million teacher texts every day, okay, that's exaggeration, maybe 200 per day, it's no fun to have it on my wrist because now my wrist is buzzing all the time. So Sorry for my editorializing. So we know that this point is 0, 1. So my y value is 1. So 1 is greater than 2/3 times 0. 2/3 times 0 is 0. Is this a true statement? Oh, geez. This is what happens when you do the same problem for a third time. I flipped the sign. There we go. Let's make sure I didn't do that over here. Okay. So, is 1 less than 0? The answer is no. That is a false statement. So therefore, 1, 0 is not part of the solution set. It does not go in the shaded region. So I'm going to shade on the other side of the boundary line. All right, look at that. Okay, good stuff. Now, for the next two, I just went ahead and gave you the answers because it's the same basic idea, same basic property that we've been dealing with in the first 4 problems. But the last two are a little bit different because you're given the equations in standard form. So let's go ahead and deal with that. All right, now graphing in standard form can be a little bit of an issue, right? Because we don't have our y-intercept, we don't have our slope. So let's turn this into y equals mx plus b. That would give me my slope and my y-intercept, which makes life much easier when graphing. My other option is making a table of values, but finding a slope-intercept form will be easier. So let's do that. So the first thing I'm going to do is I'm going to subtract 4x from both sides. So when I subtract 4x from both sides, I will get 3y is greater than 6 minus 4x. All right, divide by 3. And remember, we have to divide everything by 3, not just part of this side. So I get y is equal to 2 minus 4 thirds x. All right, so now we're ready to make our boundary line.
For anyone who is in the building, there are bagels and cream cheese at the front counter of the office, thanks to Megan Brown and her girls, Gigi and
Emmy.
So, bagels and cream cheese on the front counter of the office. Help yourself. Thanks.
All right, so if anybody wants bagels and cream cheese, come over to the school really quickly and you'll get bagels and cream cheese. All right, so my y-intercept is 2, so I'm going to go up to a y-intercept of 2. My slope is negative 4 thirds, so that is down 4. 1, 2, 3, 4 over 3. 1, 2, 3. Down 4. 1, 2, 3, 4 over 3. 1, 2, 3. And I could go backwards. So up 4. 1, 2, 3, 4 over 3. 1, 2, 3. And there we go. We get a nice little diagonal line. I almost hit my marks, but we'll pretend I did. We'll plug in 0, 0. And so here we go. When I plug in 0, 0, I get 0 is greater than 2 minus, well, if I put 0 in for here, I just get 0. So x is greater than 2. That's not true. That is a false statement. So the shaded region is not going to have 0, 0 as one of its points. So that means that I must shade above the boundary line. All right, last problem. Here we go. So let's subtract 5x. We need to get into slope-intercept form. Subtract 5x. So I get negative 2y is less than 12 minus 5x. Okay. Now, when I divide by or multiply by a negative, that means I'm going to have to flip the sign. So we're going to get y is greater than, well, that's negative 6, because a positive divided by negative is a negative. And we have negative divided by negative, so that's going to be a positive, and we get 5 over 2x. All right, so my y-intercept is 6, negative 6. Oh, geez. I need to get back to that one. What did I forget in this problem? You probably noticed, but I totally forgot to worry about the sign, didn't I? There we go. So, is this going to be an open or a closed line? Since the two sides cannot be equal, I will have an open line. The bagels totally threw me off. I'm going to blame it on the bagels. Just like for this one, in doing this problem, I realized I forgot to ask the same question in this problem. So that was helpful that I had an extra opportunity to go through it. I'm going to have an open line because the two sides cannot be equal. So let's go up 5 because my slope has a rise of 5. 1, 2, 3, 4, 5 over 2, 1, 2. 1, 2, 3, 4, 5, 1, 2. And then I can connect my dots. And just like we talked about before, this is a open line. I really wanted to say closed, didn't I? And let's plug in 0, 0, because zeros are the easiest thing to plug in. When I do that, I get 0 is greater than negative 6. That is a true statement. Therefore, 0, 0 is part of the shaded region. All right, so hopefully you found this helpful. If you have any questions, I have a conference, a Google meeting set up at 10. Feel free to join in the conversation.